Hi everyone. I want to just go over a few basic things about correlations. So we're not going to go really in depth with it, but since this is a lab class, I do want you to have at least somewhat of an idea of how data is interpreted. So a correlation is basically a linear association between two variables, and this correlation will be a number between 1 and -1. So there are positive correlations where you have one variable that increases and then the second variable also increases. It follows the same pattern. Or one variable decreases and then the other variable decreases. A negative correlation is when one variable does one thing and the second variable does the opposite, basically. So variable 1 increases, which causes variable 2 to decrease, or variable 1 decreases, which causes variable 2 to increase. So a strong correlation basically means that the data points are scattered close together along a line, a linear line, which is called a regression line. That's a strong correlation. So you might have a moderately strong correlation or a situation where data points are scattered all over the place, might indicate there's no correlation at all. Or maybe there's a very slight correlation where some of the data points are close together on the line and some are outside of it. So this picture of these different scatter plots shows the differences in the types of correlations that you can have. So in order to determine if a correlation exists, we need to calculate a correlation coefficient, and this is known as R. So in the lab, I marked this as R, but I should have had it as R squared. I just forgot to put the squared in that symbol there, but we are technically analyzing R squared, which is a coefficient of determination. And this determines how well the regression line represents the data. So when we calculate R, basically R squared is R times R. So it will represent how much of the variation can be explained by the linear relationship. So in this case, if R is negative 0.5, then R squared is 0.25. So this is indicating a negative correlation, but R squared will give you a positive number. So 25% of the total variation can be explained by the linear relationship, and the other 75% remains unexplained, basically. So it's important to remember that correlation doesn't mean that causation occurred, so there can be other variables that influence this. Like, for example, there is a high correlation between the cost of damage in a fire and the number of firefighters working to put out the fire. So does that mean we should deploy fewer firefighters when we have larger fires? That's definitely not the case. So we might see that larger fires will result in more firefighters being deployed, but larger fires also mean that they're going to produce more extensive damage generally. So there can be third variables influencing this. The only way to really determine if something causes another is to actually have a controlled experiment where you carry out with control variables or control groups and see if one variable caused the other variable to change. But correlations can give you a starting point. It can give you something to look into and to see if there are any possibilities that two variables might be related. And it's a cheaper method, so it's good for doing exploratory research to try and see what to focus on. So there are two types of correlations. A Pearson correlation is used for numerical data. So at the beginning of the course, we talked about ratio variables and numerical variables. It's ideal to be able to use a Pearson correlation and to have numerical data because um, the results will be more reflective of a linear relationship. So we will calculate a Pearson correlation using some kind of software, or you can mathematically calculate this, but in the lab we will just be calculating it using Excel, and it will give you a number. So if that number is close to 1 or close to -1, that indicates a strong correlation. So basically between about 0.8 to 0.1 is a very strong correlation. If you have a number that is closer to 0, then that's a very weak correlation. So 0 means no correlation. Close to 0 means a weak correlation. In the middle might be, kind of average, moderate correlation. Close to 1 or close to -1 is a very strong positive or negative correlation. So a positive number means it's a positive correlation. A negative number means it's a negative correlation. So if we don't have ratio variables, you can use a Spearman's rank correlation, and this is used for scaled data like Likert scales, ordinal variables, and we calculate this in a similar way. And what happens when we have ordinal variables, sometimes they aren't represented in a linear fashion. The correlation might have a curve to it, and so using a Pearson's correlation would not provide as strong of a result because it's not accounting for a pattern, it's just accounting for how well the data fits on this line. But there can still be a pattern. So the Spearman's rank correlation will pick up this pattern if it's not on a linear line, basically. So for example, in the second scatter plot, the Pearson correlation would give you a 0.878, but the Spearman correlation would give you a number that shows the relationship more clearly. So we would want to use that for the other variables. So that's basically it for correlations, and you guys will learn how to calculate both the Pearson and Spearman correlation. It's basically just putting in the Pearson function in Excel or putting in the Correl function in Excel. That's all you really have to know about how to calculate it, but interpreting it, just that relationship that we talked about, close to -1 or 1 is a strong correlation, close to 0 is no correlation or very weak correlation. To sum up, there are many different things that anthropologists might analyze. So they're interested in examining human populations. Physical anthropologists focus on examining some evolutionary trends, or they might examine osteology. They might conduct research that has applications in forensics. They might be interested in looking at health trends or human body measurements, and general lifestyle changes in terms of disease, in terms of diet and nutrition, sedentary lifestyles. There are a lot of different types of research that anthropologists do, and physical anthropologists also tend to use a lot of quantitative methodologies to carry out this research. So throughout this course, I've tried to show you some of those types of methods and questions that we ask. So that's basically everything for the course, and I hope you guys have a good rest of the summer and take care.